Across the endless dark ocean of the cosmos, humanity has always looked upward, wondering if somewhere out there another world might breathe with life. 4 light-years from our Sun, orbiting a faint red star, lies a planet slightly larger than Earth that may hold liquid water on its surface even now. Astronomers call it Proxima Centauri b, and it represents the first step in humankind's greatest journey, the hunt for other worlds where biology might flourish. This search has already led scientists to thousands of planets orbiting distant suns, each offering a glimpse into the astonishing diversity of the universe. Some of these worlds hide oceans beneath shells of ice. Others rotate so slowly that one side forever faces the day while the opposite side sleeps in eternal night. There are places where rain is made of diamonds, where skies shimmer with alien chemistry, and where a single rotation lasts longer than an Earth year. Each discovery brings us closer to answering the oldest question ever asked. Are we alone, or is life a universal phenomenon written into the fabric of space and time? To understand where life could exist, scientists have distilled the requirements into a cosmic recipe, a simple list of ingredients that must come together in perfect harmony. The first element is the most obvious, yet the most elusive: liquid water. It is the universal solvent, the medium in which chemistry can awaken and organize itself into living forms. But water remains liquid only within a narrow range of conditions. Astronomers call this the Goldilocks zone, the orbital distance where temperatures remain not too hot and not too cold, just right for oceans, rivers and rain. Too close to the parent star and a planet's seas would boil away, turning the surface into a furnace of steam and rock. Too far away and everything freezes solid, creating a silent globe locked in ice. Earth rests perfectly within this habitable belt, about 93 million miles from the Sun, where water can coexist as liquid, vapor and ice, driving the cycles that sustain all known life. The second ingredient in this cosmic formula is an atmosphere, an invisible blanket of gases that shields a planet and regulates its temperature. The right mixture traps heat gently, while still letting sunlight reach the surface. Without this balance, a planet either scorches or freezes. Imagine wrapping yourself in a coat, thick enough to keep you warm, but breathable so you do not suffocate. Our neighbour Venus shows what happens when that balance fails. Its atmosphere is so dense with carbon dioxide that the temperature on the surface climbs to 900 degrees Fahrenheit, hot enough to melt metal. The third essential component is less visible but equally vital: a magnetic field. This unseen shield protects a planet from the constant assault of cosmic and solar radiation. Without it, charged particles streaming from a star would erode the atmosphere molecule by molecule until nothing remains. Mars, for instance, once hosted rivers and perhaps oceans, but when its magnetic field faded, the solar wind stripped away its air, leaving behind a barren, frozen desert. To create a truly habitable world, all three of these elements, liquid water, a stable atmosphere, and a strong magnetic field, must coexist for millions or even billions of years. The planet's orbit must remain steady, neither drifting too close nor too far from its star. Its mass must be large enough to hold onto its atmosphere, but not so massive that it becomes a gas giant. Even the behavior of the parent star matters. It must shine consistently, calm enough to avoid flares that could sterilize the surface, yet active enough to provide steady warmth. Out of more than 5,000 exoplanets now confirmed, fewer than 50 lie in that narrow region where all these conditions might align. Each of those rare worlds could be a potential second Earth, a place where alien skies reflect across alien oceans, and perhaps where some form of life is unfolding its own story right now. Finding such planets amid the endless black sea of space is like searching for a single grain of sand on an infinite beach. To locate them, astronomers have built instruments capable of detecting the faintest flicker of starlight as a planet crosses its sun, dimming the star by less than a fraction of a percent. These space telescopes measure worlds so distant that their light takes years to reach us, revealing their size, orbit, and sometimes even hints of their atmosphere. Every detection feels like a whisper from across the void, a reminder that our solar system is not unique. Somewhere out there, in the gentle glow of another star, water might ripple against alien shores, clouds might gather over mountain peaks, and perhaps something is looking back wondering the same thing we do. The journey to find life among the stars has only just begun, but even the search itself has changed how we see our place in the universe. Earth, once thought to be the centre of everything, is now understood as one fragile oasis among billions. The conditions that allow us to exist are astonishingly rare and delicately balanced, yet they prove that life can take root when the ingredients align. As we prepare to step further into the cosmic unknown, we are not merely looking for other planets, we are looking for reflections of ourselves, scattered across the endless night. Just beyond the boundary of our solar system, in the faint red glow of the star next door, lies a world that has captured the imagination of astronomers and dreamers alike. Proxima Centauri b, orbiting the dim red dwarf Proxima Centauri just over 4 light-years away, is the closest known planet outside our own solar system that might sustain conditions suitable for life. It is a small, rocky planet slightly larger than Earth, circling its star once every 11 days. That short orbit places it squarely within the star's habitable zone, where liquid water could, in theory, exist on its surface. Yet proximity alone does not guarantee comfort. Life near a red dwarf star faces challenges we can scarcely imagine. Proxima Centauri is cooler and smaller than our Sun, but it is also far more temperamental. It often erupts with flares bursts of radiation powerful enough to strip away a planet's atmosphere or bathe its surface in lethal ultraviolet light. These stellar tantrums would be catastrophic for life as we know it. And yet, hope remains, because even in such harsh conditions, the universe has a way of adapting. Scientists believe that if Proxima Centauri b possesses a strong magnetic field, like Earth's, it might be able to deflect much of the radiation. The magnetic field could act as a shield, protecting the planet's air from erosion and giving potential life a chance to survive beneath the skies of an alien sun. But Proxima b's environment is unlike anything on Earth. Due to its close orbit, the planet is almost certainly tidally locked, meaning one hemisphere constantly faces the star while the other remains in endless darkness. On the day side, temperatures could rise high enough to boil away surface water, while the night side might freeze solid. In between these extremes lies a narrow twilight band, the terminator zone, where day and night meet in perpetual dusk. This twilight ring could be the most promising refuge for life, a band of balance between fire and ice. Here winds would sweep from the blazing day side to the frigid night, distributing heat and perhaps stabilizing the climate enough for oceans or lakes to persist. In this eternal evening, alien skies might glow faintly red, and any organisms that evolved there would have to adapt to dim, ruddy light. Photosynthesis, if it existed, would rely not on yellow sunlight but on the longer, cooler wavelengths of a red dwarf. Plants, if such life arose, might not be green but deep purple or black, optimized to absorb every photon of their faint sun. The surface of Proxima b could tell an extraordinary story. If the planet has continents and oceans, its landscapes would look nothing like Earth's. The water cycle might move slowly, driven by gentle evaporation on the warm side and condensation near the borderlands of the terminator. Clouds could hover eternally in the same place, creating vast belts of storms where the light fades into night. The wind might carry ice crystals from the frozen hemisphere into regions where they melt and rain back down again, a planetary rhythm shaped by the star's relentless pull. Beneath the surface, geothermal activity could play an essential role. Even if parts of the planet are frozen, volcanic heat from the interior might create pockets of warmth where liquid water survives underground. Such conditions could shelter microbial life, protected from radiation by rock and soil. On Earth, similar ecosystems thrive around hydrothermal vents deep in our oceans, feeding not on sunlight, but on chemical energy. If Proxima b has similar energy sources, it might not need bright days or calm weather to sustain life. It would only need stability and time. The discovery of Proxima Centauri b in 2016 marked a turning point in astronomy. For the first time, a potentially habitable planet had been found not in some distant, unreachable system, but practically next door in cosmic terms. At a distance of 4.24 light-years, it lies close enough that future generations might one day send robotic probes to study it directly. Projects like Breakthrough Starshot are already exploring the possibility of using laser-driven spacecraft tiny, lightweight vehicles accelerated to a fraction of the speed of light to reach Proxima b within a single human lifetime. If that dream becomes reality, we may finally see what this mysterious world truly looks like. Will it be a barren desert scarred by radiation? or a twilight paradise with seas reflecting the red shimmer of its star? The answer could redefine how we think about life in the universe. Because if life can exist there, clinging to existence under the light of a volatile red dwarf, then life might not be the exception, it might be the rule. Proxima Centauri b reminds us that habitability is not a single formula, but a spectrum of possibilities. Some worlds may host life beneath thick atmospheres, others under ice, and some in the dim light of eternal dusk. The universe, vast and inventive, finds ways to turn even the most hostile environments into potential homes. As our instruments improve and our reach extends beyond the solar system, Proxima Centauri b stands as a beacon of both curiosity and humility. It is a reminder that our cosmic neighbourhood is far from empty, and that the line between lifeless rock and living world may be far thinner than we ever imagined. In a small corner of the constellation Aquarius, 40 light-years from Earth, a faint red star glows with a soft, steady light. To the naked eye it's invisible, but to astronomers it has become one of the most fascinating systems ever discovered. This star, known as TRAPPIST-1, is no larger than Jupiter and only a fraction as bright as our Sun, yet around it orbits a family of 7 Earth-sized planets, a cosmic harmony unlike anything we've seen before. Each of these worlds dances around its parent star in a precise rhythm, locked in an orbital resonance that keeps them gravitationally balanced like musical notes played in perfect sequence. The planets are named simply TRAPPIST-1b through TRAPPIST-1h, and though their names sound technical, their existence has inspired endless wonder. 3 of them, TRAPPIST-1, F, and G, fall within the habitable zone, where temperatures might allow liquid water to exist. That makes this small red star one of the most promising locations in our galaxy for studying potentially habitable worlds. If an observer could hover above the TRAPPIST-1 system, the view would be mesmerizing. The planets are so close to one another that from the surface of one world, you might see the neighbouring planets appearing larger in the sky than our own moon does from Earth. Their years are short, ranging from a mere day and a half for the innermost planet to about 20 days for the outer ones. Because the star itself is dim and cool, these tight orbits don't bake the planets. They instead keep them warm enough for the possibility of oceans, clouds, and maybe even atmospheres. Yet, as with all red dwarf systems, the story is not without its dangers. TRAPPIST-1, though quieter than many red dwarfs, still emits bursts of radiation. The planets that orbit so close could have their atmospheres eroded by powerful stellar winds. Whether they have managed to hold on to their air is one of the key mysteries that astronomers are racing to solve. The James Webb Space Telescope has already begun examining the system's light in exquisite detail, searching for the chemical fingerprints of gases such as oxygen, carbon dioxide, and water vapour. Each measurement, each faint fluctuation in the star's light, carries the potential to reveal whether these worlds are bare rocks or living planets. What makes TRAPPIST-1 so extraordinary is how compact and synchronized it is. The entire system could fit comfortably within the orbit of Mercury, yet within that small space, 7 worlds maintain a delicate gravitational choreography that has lasted for billions of years. It is a cosmic clockwork, where each planet's orbit gently tugs on the others in a pattern of subtle resonances that prevent catastrophic collisions. Such balance suggests the system formed slowly and peacefully, allowing each world to settle into its place. Because the star is so faint, the light on these planets would be dim and reddish, casting perpetual twilight across their landscapes. On some of them, the skies might glow in hues of deep crimson or rust, while others could shimmer under perpetual dusk. If any of the planets are tidally locked, as scientists suspect, each world would have one face that forever looks toward its star and another that never sees daylight. Between them would lie a terminator zone, a region of eternal sunset where temperatures could be moderate enough for life. Imagine standing in that twilight region on TRAPPIST-1e. The sky above would be streaked with the faint glow of the red star, its light soft but constant. On the horizon, you might see another planet hanging close enough that its mountains and oceans are visible to the naked eye. The air, if it exists, might carry a faint warmth, and winds could flow from the bright side to the dark, distributing heat in endless circulation. Water could collect in vast ring-shaped oceans circling the planet's equator, illuminated by the dull crimson sun. It's a vision of beauty both alien and familiar, a system that mirrors our own in miniature yet feels utterly foreign. Scientists are particularly intrigued by TRAPPIST-1e, often called the most Earth-like of the seven. It is slightly smaller than our planet, likely rocky, and receives nearly the same amount of energy from its star as Earth does from the Sun. If it possesses an atmosphere, it could maintain surface temperatures suitable for liquid water. Some models even suggest that a thin layer of carbon dioxide could keep the planet comfortably warm. Its siblings, TRAPPIST-1f and G, orbit farther out, perhaps colder, but not necessarily lifeless. Thick atmospheres or internal heat could make them stable enough for liquid water beneath icy shells, much like the moons Europa and Enceladus in our own solar system. In a universe of extremes, the TRAPPIST-1 system stands as a masterpiece of moderation. 7 small worlds, each potentially unique, orbiting a single quiet star, a natural laboratory for understanding how common habitable planets might be. The discovery of this system reshaped our perception of where life might emerge. It reminded us that even the faintest, most unassuming stars could host entire families of worlds, any one of which might harbour oceans, clouds, or even life forms waiting to be discovered. If there is a place beyond our solar system where we might one day find unmistakable signs of biology, the TRAPPIST-1 system remains one of our brightest hopes. Its compact elegance and balance are a cosmic symphony, and as we continue to listen to its silent music through our telescopes, we may soon learn whether its melody is one of mere rock and dust, or one that sings of life among the stars. Roughly 400 light-years away in the constellation Cygnus, a pale sun glows quietly, orbited by a planet that has been nicknamed Earth's older cousin. This world, Kepler 452b, was discovered by NASA's Kepler Space Telescope in 2015 and immediately captured attention across the scientific community. For the first time, astronomers had found a rocky planet orbiting within the habitable zone of a star so similar to our own. In many ways, it seemed like a mirror of Earth, yet older, larger, and more evolved, a possible glimpse of our planet's future billions of years from now. Kepler 452b orbits its parent star, Kepler 452, once every 385 days, nearly identical to Earth's year. That orbital distance places it in the perfect range where temperatures could allow liquid water to persist on the surface, assuming it has an atmosphere. The planet's radius is about 60% larger than Earth's, and though its exact mass remains uncertain, scientists estimate it could be up to 5 times heavier, implying stronger gravity and a denser composition. Such a world would have mountains higher than ours and clouds that drift more slowly across its sky. To an astronaut standing there, the pull of gravity would make every step feel deliberate and heavy, each breath drawn from a thicker atmosphere tinted by the light of an older, yellower sun. Kepler 452 itself is about 6 billion years old, 1.5 billion years older than our own sun. This means its habitable zone has been stable for an exceptionally long time, potentially allowing life to evolve and mature over vast epochs. If any form of biology once arose there, it would have had more time to develop complexity than life on Earth has so far. But that same age also hints at a darker truth. Stars like Kepler 452 slowly brighten as they age, and this gradual warming can transform once pleasant worlds into ovens. If Kepler 452b began as a lush, ocean-bearing planet, it may now be entering a greenhouse phase, its seas evaporating as the star's energy increases. Over millions of years, water vapor in the atmosphere could trap more heat, accelerating the process until only arid deserts remain. In that sense, Kepler 452b might be a time machine, a vision of what Earth could look like in another billion years, as our sun continues to evolve. When NASA scientists first described Kepler 452b, they called it the closest thing we've found to Earth 2.0. It orbits a star that's nearly identical to ours, sits within a similar zone of warmth, and may have a rocky surface capable of supporting oceans. Yet its subtle differences make it uniquely fascinating. Being larger and heavier means it could hold on to its atmosphere more effectively, perhaps creating thicker air that moderates temperature extremes. That same density, however, might make plate tectonics sluggish or non-existent, which could hinder the recycling of carbon dioxide, a process essential for stabilizing climate. Without this geologic balance, greenhouse gases could build up unchecked, driving the planet toward a Venus-like fate. Still, the possibilities are endless. Some models suggest that even with increased stellar heat, cloud coverage could reflect enough sunlight to keep the planet temperate, especially near the poles. Others imagine vast, shallow seas surviving in the cooler regions while the equatorial zones bake beneath constant sun. Every scenario tells a slightly different story, but all paint Kepler 452b as a world in transition, a planet straddling the line between habitability and decline. For scientists, this balance offers invaluable insight into planetary evolution. Studying Kepler 452b helps researchers understand how long a world like Earth can sustain life before its star becomes too bright. It also challenges the idea that habitability is static. Instead, it may be a moving window of opportunity that slowly opens and then closes over time. The conditions for life, it seems, are not permanent but fleeting, shaped by cosmic cycles measured in billions of years. To imagine what life might once have been like, there is to imagine an Earth grown old. Perhaps once Kepler 452b had vast blue oceans, drifting continents, and cloud systems that mirrored our own. Over time, as its star aged, forests, if they ever existed, would have withered under an intensifying sun, and oceans would have receded into dust. If any intelligent beings evolved there, they may have faced the same challenges humanity one day will: rising temperatures, shrinking water supplies, and a slow but unstoppable shift toward desolation. In that way, Kepler 452b becomes not just a distant exoplanet, but a reflection of our destiny, a warning written across the stars. From a cosmic perspective, the discovery of this planet was monumental. It proved that worlds like ours orbit not only young stars but also ancient ones. It showed that habitability can persist for billions of years, but not forever. And it reminded us that the forces that shaped our own home are universal, operating everywhere from nearby systems to the farthest corners of the galaxy. Kepler 452b may or may not be alive today, but its existence tells a story of endurance and change. It stands as a silent witness to time itself, a planet that could once have been teeming with life, now aging gracefully under the light of a star that refuses to stay constant. To gaze upon it through our telescopes is to glimpse both our origin and our end, united by the same delicate balance that sustains life across the cosmos. In the grand scheme of space and time, Kepler 452b reminds us that every world, no matter how beautiful, exists within limits. The stars that give life also take it away, not through violence, but through the slow, inevitable rhythm of evolution. And so, in that ancient light shining from Cygnus, we see our own reflection, an echo of what was, and a whisper of what is yet to come. Amid the ever-growing catalogue of alien worlds, one new discovery has drawn particular interest for its combination of familiarity and strangeness. Astronomers call it TOI 715b, a planet roughly 1.5 times the size of Earth, that circles a small, cool star located just over 100 light-years away. The letters TOI stand for TESS Object of Interest, a reference to NASA's Transiting Exoplanet Survey satellite, which continues to uncover worlds hidden in the faint flickers of starlight. TOI 715b may not look extraordinary on paper, but what makes it remarkable is where it resides, right in the conservative habitable zone of its parent star, the narrow region where liquid water could potentially exist on a planet's surface. What's even more astonishing is how quickly it moves. While Earth takes 365 days to complete its journey around the Sun, TOI 715b whirls around its host star in just 19 days. The year there passes in less than 3 weeks by our standards, yet because the star is a cool red dwarf emitting far less energy than the Sun, the planet still receives a similar amount of warmth. It's a cosmic balancing act where proximity replaces power, a tight orbit around a dim ember of a star producing conditions that might still nurture life. From space, the system would appear serene. The parent star, smaller and redder than our Sun, glows softly against the blackness, casting its dim light on the world that huddles close. The planet likely keeps one face always turned toward its star, a result of tidal locking, meaning one side endures constant daylight, while the other remains trapped in endless night. The day side might shimmer under a ruddy glow, with skies tinted orange or crimson, while the night side lies buried beneath frozen darkness. Between them could stretch a twilight ring, an eternal belt of dusk, where temperatures even out, where ice melts and water flows. That boundary might be the most promising region for life, a zone of balance amid extremes. Scientists are still uncertain whether TOI 715b has an atmosphere, but if it does, it could play a crucial role in distributing heat from the bright side to the dark, smoothing out the temperature differences and preventing the planet from becoming a frozen wasteland or a scorched desert. A thick blanket of air rich in carbon dioxide or nitrogen could trap warmth just enough to keep liquid water stable. It's even possible that persistent winds circle the planet, carrying clouds and moisture from the illuminated hemisphere into the perpetual night and back again in a rhythmic cycle. On Earth, such a process drives weather. On TOI 715b, it could be the heartbeat of habitability. The discovery of this world came at a time when astronomers were refining their understanding of red dwarf systems. Red dwarfs make up the vast majority of stars in our galaxy, and many host small rocky planets. Because these stars are long-lived, often surviving for hundreds of billions of years, they provide stable environments over cosmic timescales. That longevity increases the odds that life, if it ever begins, could persist long enough to evolve complexity. T715b's host star, being quiet and relatively inactive, adds another layer of hope. Many red dwarfs are notorious for violent flares that can strip away planetary atmospheres, but so far, this star seems gentle. It shines steadily, bathing its planet in calm reddish light. For astronomers searching for life, this is an encouraging sign. If the planet retains its air and water, it could be a stable world where biology might endure for eons. The planet's larger size means its gravity would be stronger than Earth's. Walking there would feel heavy, as though every movement required more effort. The higher gravity could also help the planet hold onto a dense atmosphere, one capable of protecting its surface from cosmic radiation. Its extra mass might fuel internal heat, driving plate tectonics and volcanism that release gases into the air, replenishing it over time. That geological activity could keep the climate in balance, preventing the extremes that doom lifeless planets. TOI 715b represents a fascinating middle ground in the diversity of exoplanets, a world neither too large nor too small, neither too hot nor too cold. It is the kind of place that expands our imagination of where life could thrive. It might be covered in oceans reflecting the dim light of its red sun, or it might be a rocky desert with scattered lakes glimmering in the eternal twilight. We don't yet know its surface composition, but instruments like the James Webb Space Telescope are already turning their gaze toward it, searching for signs of an atmosphere and the fingerprints of molecules like methane or oxygen. If any of those signals are detected, it would mark a profound milestone in our search for life beyond Earth. For now, TOI 715b is a promise candidate that teases us with possibility. Its discovery shows how quickly our understanding of the cosmos is evolving. Only a decade ago, finding such a world would have been headline news. Now we're identifying multiple potentially habitable planets every year, each one bringing us closer to answering that ancient question about our place in the universe. TOI 715b may not be a twin of Earth, but it reminds us that the conditions for life can emerge in many forms, around many kinds of stars. Somewhere in that dim red light, perhaps beneath thick clouds and a perpetual sunset, something could be stirring, a chemistry awakening, a biology adapting, a new story of life beginning to unfold under alien skies. In the quiet darkness between the stars, about 120 light-years away in the constellation Leo, drifts a world unlike any we have ever known, a planet called K2-18b. When astronomers first detected it using data from NASA's Kepler spacecraft, it seemed unassuming. Larger than Earth, but smaller than Neptune, orbiting a small red dwarf star. Yet as scientists looked closer, they found something extraordinary. For the first time in history, a planet beyond our solar system had revealed the unmistakable signature of water vapor in its atmosphere. That discovery changed everything. Suddenly, the distant world of K2-18b was no longer just another dot in the cosmic catalogue. It was the most promising place yet for finding the essential ingredient of life. K2-18b orbits its star once every 33 days, nestled within the habitable zone where temperatures could, in theory, support liquid water. But the planet itself is not a simple twin of Earth. It's roughly 8 times our planet's mass and about 2.5 times its diameter, placing it in a category astronomers call a super-Earth, or mini-Neptune. That size suggests a thick atmosphere composed of hydrogen and helium, perhaps with layers of water vapor and clouds floating high above a rocky or icy core. Beneath those clouds, the surface, if one exists, might be cloaked in dense fog or even submerged beneath a global ocean hundreds of kilometers deep. It is a world of extremes, part gas giant, part water world, existing somewhere between the familiar and the alien. When astronomers used the Hubble Space Telescope to analyze its atmosphere, they observed light from the host star filtering through the planet's gases during a transit. The faint fingerprints of water vapor were unmistakable. For the first time, humanity had proof that an exoplanet within the habitable zone possessed water in its skies. The implications were staggering. Water, the cradle of all known life, existed far beyond our reach, drifting around a distant red sun. Later observations with the James Webb Space Telescope refined that view even further. Webb detected not only water vapor, but also potential signs of methane and carbon dioxide gases that, on Earth, are closely tied to biological processes. Scientists cautioned that these signals do not confirm life, but they demonstrate that K2-18b's chemistry is complex and dynamic. It is a living laboratory for understanding how atmospheres evolve and how ingredients for life assemble across the galaxy. To imagine standing or perhaps floating on K2-18b is to enter a realm of mystery. The light from its star would bathe everything in a deep crimson hue. The sky might be filled with thick clouds that glow softly from scattered sunlight. Winds could sweep through the upper atmosphere at tremendous speeds, churning the vaporous layers like a slow-motion storm. If an ocean lies below, it would be immense and crushingly deep, with pressures far beyond anything experienced on Earth. Any life that formed there would have to adapt to conditions more like those found in the dark depths of our own oceans than in sunlit shallows. Perhaps microbial life could cling to chemical gradients near the ocean's base, feeding on the energy from the planet's core rather than on sunlight. The boundaries of possibility stretch far wider than we once imagined. K2-18b challenges the very definition of habitability. For decades, scientists assumed that only rocky worlds similar to Earth could host life, but this planet blurs those lines. Its thick hydrogen atmosphere might create a greenhouse effect that keeps its ocean warm even though the star it orbits is much dimmer than our Sun. This has led researchers to introduce a new category, Hycean worlds, a blend of hydrogen and ocean. These are planets enveloped by hydrogen-rich air and possibly covered by deep seas, capable of sustaining liquid water and perhaps even biology. K2-18b is the prototype of this new class, a world that defies our expectations yet fits perfectly into nature's boundless creativity. The discovery also represents a triumph of technology and patience. Detecting the faint spectral fingerprints of water molecules across light years of space requires instruments of almost unimaginable precision. The fact that we can now measure the chemistry of an alien world's sky shows how far our species has come in just a few decades. From the first exoplanet detection in 1995 to the identification of water vapor in 2019, humanity has transitioned from dreaming about other worlds to studying their weather. Each new measurement deepens our understanding not only of distant planets, but of our own. K2-18b may not resemble Earth, but it offers a window into the processes that shape planetary climates and make life possible. It reminds us that the ingredients for biology, water, carbon and energy, are not confined to our solar system, but are scattered generously throughout the cosmos. Perhaps worlds like this are common, quietly circling the countless red stars that fill the galaxy. As we continue to observe K2-18b with next-generation telescopes, we may learn whether it truly harbours a liquid ocean, and whether its atmosphere bears the subtle chemical imbalance that could hint at life. For now, it stands as a symbol of possibility, a distant sphere where water falls as mist in a crimson sky, where seas might stretch endlessly beneath alien clouds, and where the story of life could be writing its next chapter, unseen, across the gulf of space. About 23 light-years away, in the direction of the constellation Scorpius, lies a small red star surrounded by a trio of planets, one of which has long fascinated scientists searching for life beyond our solar system. This world is known as Gliese 667cc, and though it receives only a third as much energy from its star as Earth does from the Sun, it may still be warm enough to cradle life. It orbits a star that is cooler, dimmer, and far longer lived than our own, a red dwarf that burns steadily for trillions of years. Gliese 667cc completes a full orbit in just 28 days, which places it squarely within the star's habitable zone. But because it lies so close to its parent, the planet is almost certainly tidally locked. That means one hemisphere faces its star in perpetual daylight, while the other is forever lost in darkness. The concept of a tidally locked world sounds alien and hostile, yet it might be more stable than it seems. On the day side of Gliese 667cc, the star would hang motionless in the sky, never setting, never rising, locked in a fixed position above the horizon. The light would bathe the landscape in a deep red glow, dimmer than a cloudy afternoon on Earth, but constant. Temperatures there could soar, perhaps turning the ground into a sun-baked desert, or a sea of molten rock near the substellar point. Meanwhile, the night side would lie in eternal frost, lit only by the faint reflection of the star's glow from the atmosphere, or from auroras ignited by magnetic storms. Between those extremes lies a narrow region, the terminator zone, where day fades into night, a thin twilight belt that circles the planet. Here, temperatures might be just right for liquid water to flow, and winds might carry warmth from the blazing side to the frozen one. If any place on Gliese 667cc could sustain life, it would be this twilight ring, a land of perpetual sunsets stretching endlessly around the globe. Imagine standing there beneath a crimson sky, where the star lingers permanently on the horizon, neither rising nor setting, painting the clouds in shades of red and violet. The air might shimmer with the constant movement of heat and cold, driving powerful winds that never cease. On one side, the world glows bright and fiery. On the other, darkness swallows everything. Life, if it exists here, would have evolved to thrive on stability within chaos. Plants or photosynthetic organisms might adapt to the dim red light, absorbing every photon from the weak star. Their pigments could be black or deep purple, maximizing energy intake from the narrow wavelengths available. On the darker side, other forms of life might depend on chemical or geothermal energy, clustering near volcanic vents or in subsurface habitats warmed by the planet's interior. The contrast between these two hemispheres creates a dual world, one of light, one of shadow, each influencing the other through the circulation of atmosphere and water. Computer simulations suggest that a planet like Gliese, 667cc, could maintain a surprisingly stable climate if it has a thick enough atmosphere. Carbon dioxide and water vapor could trap heat efficiently, while global winds distribute that warmth across the planet's surface. The result would be a dynamic but balanced system where the night side doesn't freeze entirely and the day side doesn't burn. Clouds could form over the terminator region, creating perpetual storms that recycle water between hemispheres. Rain might fall continuously in that eternal dusk, feeding rivers that flow toward both light and dark, freezing or evaporating as they reach their ends. For scientists, Gliese 667cc is a reminder that habitability doesn't always mean Earth-like. A planet doesn't need a rotating day-night cycle or a yellow sun to host life. It only needs energy, chemistry, and stability over time. Red dwarfs like Gliese 667c provide that stability for unimaginably long periods, giving biology plenty of opportunity to take root. If this world indeed harbours life, it may have been evolving there for billions of years already, adapting to its unique rhythm of constant day and night. The discovery of Gliese 667c was one of the early triumphs of exoplanet research. Before telescopes like Kepler and TESS revealed thousands of candidates, this planet stood as one of the best-known potentially habitable worlds. Its existence proved that even small stars could host Earth-sized planets in zones where liquid water might persist. Since then, astronomers have used it as a model for studying climate patterns on tidally locked worlds. Understanding how heat moves between hemispheres helps us predict what kinds of atmospheres could survive in these systems. It also widens our imagination of what habitable truly means. To live on Gliese 667c would be to inhabit a realm of eternal twilight, a place where day and night are not moments in time but fixed locations on a map. It would be a planet where every horizon marks the border between two extremes, and where the only constant is the glow of a red sun frozen above the horizon. The creatures that might roam such a world would know neither dawn nor dusk, only the timeless dance between warmth and cold. Perhaps they would build their homes along the narrow strip where light and shadow meet, forever balanced between the two. Plica 657c reminds us that life may not require a world identical to ours. It may flourish under different skies, different rhythms and different suns. In the vast tapestry of the galaxy, there are countless planets like this one half, bathed in fire, half cloaked in ice, each whispering the same quiet message, that the universe is far more inventive and generous than we ever dared to believe. Far beyond the reach of our sun, nearly 42 light-years away in the constellation Pictor, circles a star smaller and quieter than ours. Around it orbits a remarkable planet HD 4307G, a world that offers a strange reflection of Earth yet plays by entirely different rules. It is a super-Earth, roughly 7 times our planet's mass, and it travels through its orbit in about 200 days. That path places it comfortably within the habitable zone, the region where temperatures could allow liquid water to exist. But unlike the serene stability of our world, HD 4307G is governed by a rhythm of extremes, a cycle of seasons that can last for decades, sculpted by the deep tilt of its axis. On Earth, our planet leans just over 23 degrees, creating seasons that change gently as we orbit the Sun. But on HD 4307G, computer simulations suggest a much more dramatic inclination, perhaps 40 degrees or more, causing seasons that stretch across lifetimes. Summers could linger for 20 or 30 years, scorching continents beneath relentless sunlight, followed by winters of equal duration when the world plunges into darkness and ice. This long, slow oscillation would transform climate, geography, and even the nature of life itself. On such a planet, adaptation wouldn't be measured in months but in generations. Creatures born in endless summer might never know the chill of winter, while their descendants could grow up in frozen valleys and never see the warmth of the sun. Forests could migrate over time, creeping toward the poles as warmth expands, retreating again as the cold advances. Oceans might freeze and thaw in vast cycles, reshaping coastlines and ecosystems in a repeating planetary heartbeat that lasts centuries. The parent star, HD 4307, is an orange dwarf A K-type star cooler and dimmer than the Sun. It emits a soft amber light that would paint the sky of its planet in warm hues, turning clouds gold and copper at all hours. Though smaller than the Sun, this star is stable and long-lived, burning through its fuel slowly and steadily. Such a star offers ideal conditions for life, providing energy across billions of years without the violent flares that plague many red dwarfs. Yet the planet's distance and tilt mean that stability gives way to drama on the surface. As the years unfold, massive storms could sweep through the atmosphere, driven by temperature contrasts between hemispheres. During long summers, warm air might rise and rush toward the cold hemisphere, creating continuous jet streams that circle the globe. Enormous weather systems could dominate entire continents, producing storms that last for months or even years. During winter, frozen oceans might lock up vast amounts of water, lowering sea levels and exposing new land. Then, as the planet tilts back, the ice would melt, flooding valleys and creating new inland seas. Life, if it exists there, would have to endure constant transformation, a dance between abundance and scarcity. Plants might evolve to store energy for decades, remaining dormant during the cold ages and erupting into growth as the warmth returns. Animals could hibernate for years or migrate across continents in search of milder climates, following the shifting frontier between ice and sunlight. Some forms of life might even rely on long-term biological clocks, sensing the gradual change of temperature and light to prepare for the next epochal shift. For humans imagining a future colony, HD 4307G would be both a paradise and a challenge. Its greater mass would produce stronger gravity. Standing there would feel as if you carried twice your own weight. The thick atmosphere, held tightly by that gravity, might protect the surface from radiation, but also create dense, heavy air that moves sluggishly. Walking through such an atmosphere might feel like moving underwater. Mountains could rise higher than any on Earth, sculpted by slow tectonic forces under immense pressure. Rivers might carve deep canyons through orange-tinged rock, fed by meltwater from receding glaciers at the edges of long winters. The sky would likely appear dim but colourful, glowing in shades of amber and rose. From orbit, the planet might look like a marble of gold and blue, its continents shifting in hue as centuries pass from warm to cold and back again. For astronomers, HD 4307G is a compelling mystery. It was discovered not by direct imaging, but through the subtle tug it exerts on its star, a faint wobble in starlight that repeats like a heartbeat every 200 days. That tiny signal revealed one of the most Earth-like candidates ever found, and yet one of the most alien. It teaches us that habitability is not a simple equation of distance and temperature. It depends on the deep, complex interplay of rotation, tilt, atmosphere, and time. While Earth's rhythm of seasons feels comforting and familiar, HD 4307G reminds us that other worlds may live on much grander timescales. Perhaps somewhere beneath its golden skies, evolution unfolds in slow motion, each generation shaped by epochs of plenty and scarcity. The creatures that survive there would embody resilience beyond our imagination. They would learn to endure change not as an anomaly, but as the essence of existence. To explore such a planet, even through the lens of science, is to glimpse how diverse the story of life could be. HD 4307G may never host civilizations like ours, but it stands as a symbol of adaptability. The idea that life, in whatever form it takes, can find balance even in a world that never stands still. In its long seasons, in its endless cycles of transformation, this distant planet whispers a truth that resonates across the universe, that change is not an obstacle to life, but the force that gives it meaning. Across the black gulf of space, 1,200 light-years away, there is a planet that challenges everything we thought we knew about habitability. Its name is Kepler 422b, and though it lies farther from its star than Earth does from the Sun, it is considered one of the most potentially habitable exoplanets ever discovered. Its story is not one of warmth and sunlight, but of endurance and survival in the cold. It orbits an orange dwarf star cooler, and smaller than our Sun, completing a revolution once every 112 days. That orbit places it near the outer edge of the habitable zone, a region where sunlight is faint but still capable of sustaining life under the right conditions. From space, Kepler 442b might look like a pale blue and white marble, glimmering faintly in the dim glow of its distant star. The light that reaches it would be weaker, turning its skies a coppery orange instead of blue. Temperatures on the surface might hover well below freezing, and yet beneath that frozen crust something remarkable could be happening. Many scientists believe that Kepler 442b might be an ice world, covered in glaciers and snow but warmed from within by geothermal heat. That internal energy born from the slow decay of radioactive elements and the planet's own formation could melt pockets of liquid water beneath the surface, forming vast subterranean oceans sealed under miles of ice. On Earth, such hidden seas exist in the moons of our solar system, like Europa and Enceladus, where tidal forces and heat from the core keep water in a liquid state. These alien oceans could provide perfect environments for life, protected from cosmic radiation, stable for billions of years, and rich in minerals that feed chemistry. If the same conditions exist on Kepler 442b, life could thrive in the darkness, far below the frozen plains. It might be microbial, feeding on chemical reactions between rock and water, perhaps clustered around geothermal vents like those found in Earth's deep oceans. These organisms wouldn't need sunlight at all. They would live by harnessing the planet's internal energy, proving that biology doesn't depend solely on the warmth of a star. Kepler 442b is about 1/3 larger than Earth, and likely more massive, which means it could have a dense atmosphere. That atmosphere might trap heat effectively, preventing the surface from becoming an absolute wasteland. If the air is thick with carbon dioxide or methane, the greenhouse effect could raise the temperature just enough to keep patches of liquid water near the equator or beneath thin ice layers. The idea that a frozen planet could still be habitable may seem counterintuitive, but nature has already written that story many times. On Earth, microbial life has been found thriving in Antarctic ice, in deep glacial lakes sealed off for millions of years, and in permafrost older than human civilization. If life can survive those extremes here, it's not difficult to imagine similar forms enduring on Kepler 442b. Perhaps beneath the icy crust lies a global ocean, vast and silent, stretching across the entire planet. The water might glow faintly blue from bioluminescent organisms drifting in the dark. If intelligent life ever emerged there, it would live in a world without stars, guided only by the faint rhythms of the planet's interior heat. Above the ice, the surface would be harsh and hauntingly beautiful. Great mountain ranges could rise through the frost, their peaks glinting in the dim red-orange light of the star. Vast glaciers might crawl slowly toward the equator, grinding rock to dust as they move. Every 100 years, as the planet's orbit shifts slightly, parts of the surface might thaw briefly, creating rivers that flow for a season before freezing again. These fleeting periods of warmth could spark bursts of biological activity. Short windows when the frozen world comes alive, only to fall asleep again beneath the snow. For scientists on Earth, Kepler 442b represents a new category of habitability, the cold frontier. It shows that life might not only survive but also flourish under conditions that seem hostile to us. The key ingredient is not temperature alone but energy, water, and stability. Even a dim star and a frozen crust can support life if the balance is right. Studying worlds like Kepler 442b also helps us understand our own planet's past. Billions of years ago, Earth may have experienced snowball phases where nearly the entire surface was covered in ice. Yet even then, life persisted, hiding in the oceans and waiting for warmth to return. Kepler 442b could be locked in such a phase permanently, a world of ice sustained by an inner fire. The discovery of this planet was one of the triumphs of NASA's Kepler mission, which scanned distant stars for the faint dimming caused by transiting planets. When astronomers calculated its size, orbit, and energy balance, they realized it ranked among the most Earth-like worlds ever found. Yet its very differences, its coldness, its possible oceans, its dim skies, make it more fascinating still. Kepler 442b reminds us that life is adaptable beyond our imagination. It doesn't need blue skies, gentle breezes, or warm sunlight. It only needs a place to exist and time to evolve. Somewhere under that frozen surface, in the still blackness of a hidden sea, life could be stirring right now, unseen and unbothered by the distant starlight. It could be ancient, slow, and resilient, thriving in the silence of a world that never truly thaws. Only 14 light-years away, practically next door on the cosmic scale, lurks a small, fiery red star known as Wolf 1061. Around it orbits a world that has long captivated astronomers for its delicate balance between danger and promise. That planet, called Wolf 1061c, is a super-Earth about 4 times as massive as our own, and it sits near the inner edge of its star's habitable zone. It could be a place where liquid water might exist, but it also could be a world scorched by the wrath of a restless sun. Its story is one of tension, a world that might cradle life, yet constantly fights to keep it alive. Wolf 1061c completes one orbit every 18 days, hugging its red dwarf parent tightly. Because the star is much cooler than the sun, the planet receives roughly the same amount of energy that Earth does, though from a much closer distance. That proximity is both a gift and a curse. The warmth keeps the planet within the range where water could remain liquid, but the nearness exposes it to intense stellar activity. Red dwarfs like Wolf 1061 are known for their violent tempers, unleashing frequent flares that blast nearby planets with ultraviolet radiation and charged particles. For a planet to survive in such a neighborhood, it must be resilient. Its atmosphere would have to act like a shield dense enough to absorb the radiation, and its magnetic field strong enough to deflect the constant stream of stellar wind. Without those defenses, any early oceans or air would have been stripped away long ago, yet astronomers have reason to hope. Wolf 1061c's higher mass suggests that it could maintain a powerful magnetic field generated by a molten iron core, similar to Earth's but stronger. Its gravity might also help retain a thick atmosphere even under constant assault. If that's true, then beneath its stormy skies the surface could still be habitable, or at least survivable. The environment there, however, would be harsh. The skies might glow faintly red, tinged with the colour of the dim star. Because the planet almost certainly keeps one side permanently facing its sun, half the world would exist in unending daylight, while the other half would be locked in perpetual darkness. The day side could be blistering hot, the ground cracked and dry, baked by continuous radiation, The night side, cut off from warmth, might be frozen solid. Between these extremes lies a narrow band of twilight. The terminator region, where the temperature could be moderate enough for liquid water. If the atmosphere circulates heat effectively, winds could sweep across the globe, carrying moisture from one hemisphere to the other, creating vast belts of clouds that drift eternally around the planet. In that dim, blood-red dusk, rain might fall as the only sign of balance in a world caught between fire and ice. The chemical makeup of Wolf 1061c's atmosphere remains a mystery, but scientists are beginning to probe it using precision spectroscopy from powerful telescopes. They are searching for traces of carbon dioxide, methane, and water vapor, the fingerprints of a living world. If these gases are detected in the right proportions, they could indicate a stable greenhouse effect capable of moderating surface conditions. If not, the planet may already have crossed the line into uninhabitability. What makes Wolf 1061c so compelling is how close it sits to that line. It represents a class of worlds on the edge of survival, where the balance between warmth and radiation is razor-thin. Too little atmosphere and the world freezes. Too much heat and the oceans boil away. Its star's violent burst could strip its air, but long periods of calm might allow the planet to recover, rebuilding its sky through volcanic outgassing or chemical cycles. Life, if it ever arose there, would have to be extraordinarily tough, capable of enduring both drought and storm, light and shadow. On Earth, we know such resilience well. Microbes thrive near volcanic vents and in deserts blasted by radiation. Some survive in the vacuum of space itself. If similar organisms ever evolved on Wolf 1061c, they might retreat underground, living beneath the surface where rock and soil offer protection. They could feed on minerals or chemical energy, safe from the deadly flares above. Each eruption of the star would be a test, each calm period a chance to rebuild. Over millions of years, such a cycle could sculpt a tenacious biosphere adapted to extremes far beyond anything we've known. From a broader perspective, Wolf 1061c offers a warning and a lesson. It shows how fragile habitability can be when a planet lies too close to its star. Even small changes in energy or magnetic protection can mean the difference between life and lifelessness. Yet it also shows how resilient planets can be, how they fight to hold on to their atmospheres and their potential. In that struggle there is something almost poetic, as though the universe itself resists emptiness. To future explorers, Wolf 1061c would be a breathtaking sight, a world bathed in constant red light, with vast storms swirling at the border between day and night, and frozen mountains rising from the eternal dark. Its landscape would tell the story of a planet at war with its own star, a story of survival against impossible odds. It may never be as gentle as Earth, but it stands as proof that even in the most hostile corners of the galaxy, there are places where the seeds of life might still find a way to endure. Just 48 light-years away, in the constellation Cetus, circles a star so dim it can barely be seen even with a telescope. Yet around that faint ember revolves one of the most intriguing exoplanets ever discovered, LHS 1140b, a massive super-Earth that may be one of the best places in our galactic neighbourhood to search for life. It is a planet of quiet endurance, a world that has faced the storms of its youth and emerged intact, still cloaked in its atmosphere, still holding on to the ingredients that make life possible. LHS 1140b orbits its cool red dwarf star once every 25 days, placing it well within the star's habitable zone. That short year might seem too fast for comfort, but the star's low temperature balances the equation perfectly. Despite its close orbit, the planet receives just about half as much energy as Earth does from the Sun, which could make it temperate enough to host liquid water if conditions are right. From space, the world would appear as a deep blue orb wrapped in layers of clouds, glowing faintly under the red light of its star. Its surface gravity would be immense, nearly twice that of Earth, pulling everything downward with unrelenting force. To walk there would be exhausting, each step a deliberate act of strength. Yet that same gravity is what may have saved the planet's atmosphere from being stripped away long ago. In its youth, the parent star likely emitted powerful flares, as most red dwarfs do. Many nearby worlds around similar stars lost their air during those violent early years, becoming barren rocks. But LHS 1140b was massive enough, and its magnetic field strong enough, to withstand that assault. It held onto its air and perhaps even its water, allowing it to remain stable for billions of years. In the quiet that followed, the planet may have settled into a lasting equilibrium, a rare oasis around a small, long-lived sun. Scientists suspect that LHS 1140b could be either a rocky world with a thick atmosphere or a water-rich planet covered by a global ocean. Either scenario carries the potential for habitability. If it's a rocky planet, the dense air could act like a gentle greenhouse, keeping the surface warm enough for rain and rivers. If it's an ocean world, the water might stretch endlessly from pole to pole, forming a deep, dark sea beneath a sky illuminated by a red sun that never grows brighter nor fades. In that ocean, chemistry could be quietly at work, building the foundations of life molecule by molecule. What makes this planet particularly fascinating is its stability. The host star, LHS 1140, is unusually calm for a red dwarf. It rotates slowly, shows few flares, and provides a steady source of light. That tranquility offers a consistent environment, something life desperately needs. For billions of years, radiation levels would have remained low, allowing organic molecules to form and persist. On planets around more violent stars, such chemistry would be destroyed almost as soon as it began. Here, under the dim crimson glow, it could thrive. Observations from the Hubble and Spitzer space telescopes have revealed tantalizing clues about the planet's atmosphere. Its density suggests the presence of heavy gases like carbon dioxide and nitrogen, similar to Earth's but thicker. These gases could trap warmth and create a climate where liquid water remains stable over long periods. The James Webb Space Telescope is now studying it in greater detail, searching for the spectral fingerprints of water vapor or even more complex molecules such as methane or ozone. If those are detected, it would mark one of the most significant discoveries in human history, the first clear evidence of an atmosphere capable of supporting life beyond Earth. To imagine standing on LHS 1140b is to envision a world of gravity and silence. The horizon would seem closer, curved more sharply by the planet's size. The air would feel heavy, perhaps humid, carrying the scent of minerals and rain. The red star would hang low and constant in the sky, its light dim but steady, painting everything in shades of crimson and gold. Winds might move slowly in the thick air, whispering across oceans that reflect the star like molten copper. Life, if it exists there, would have evolved in tune with this dim serenity. Plants or photosynthetic organisms might appear black to absorb every available photon. Animals, if they exist, would move slowly under the planet's crushing gravity, adapted to endurance rather than speed. Evolution here would favour resilience and patience. The pace of life would match the star's rhythm, quiet, unhurried, eternal. For humanity, LHS 1140b represents one of the closest and most realistic destinations for studying a potentially habitable planet. Its proximity means we can study it in exquisite detail, learning not just about its composition, but also about how life might persist under conditions very different from our own. It stands as proof that not all red dwarf planets are doomed by their star's tempers. Some survive, and in their survival, they open new windows into possibility. LS 1140b is a survivor, a world that endured the fury of its youth and settled into peace. Its calm star and strong heart have preserved it for eons, making it a natural laboratory for life in the galaxy. In its quiet orbit around a faint red sun, it tells a story of endurance, that even in the smallest corners of the cosmos, where light barely reaches, there are places where life could still bloom, waiting for us to find it. In the vast ocean of stars that fill our galaxy, there are few discoveries that have captured the human imagination as powerfully as the finding of Kepler, 1649c. Located about 300 light-years away in the constellation Cygnus, this small rocky planet stands out among thousands of others for a simple reason. It looks astonishingly like home. Of all the worlds discovered by NASA's Kepler mission, Kepler 1649c comes closest to matching Earth in both size and the amount of starlight it receives. It is a mirror of possibility, a faint reflection of our own blue world orbiting a distant red sun. The planet circles its parent star, a cool M-type red dwarf, once every 19.5 days. Because the star is much dimmer than the Sun, this close orbit still places the planet comfortably within the habitable zone, where temperatures could allow liquid water to exist. Kepler 1649c is only about 6% larger than Earth, a nearly perfect twin by cosmic standards. It receives roughly 75% of the energy Earth gets from our Sun, giving it an average temperature that could support oceans and an atmosphere. For astronomers, it was an astonishing find. Hidden in the data archives for years, the planet was originally overlooked due to a computer error. Only after researchers manually re-examined the Kepler observations did they notice the faint, periodic dimming of the star's light caused by the planet passing in front of it. What they found changed the story of our search for other worlds. Kepler 1649c was not only similar to Earth in size and warmth, it also orbited a calm, relatively stable star, increasing its chances of habitability. To imagine this world is to picture a familiar yet hauntingly different scene. The light from its red dwarf star would be dimmer and softer, casting everything in shades of crimson and amber. The sky might never turn blue. Instead, it would glow with warm, perpetual twilight. Shadows would be long, and sunsets would stretch endlessly. If clouds exist there, they might reflect the star's red light, painting the horizon in metallic hues of copper and gold. On the surface, oceans, if they exist, would sparkle faintly under the faint red sun, and landscapes could be dotted with mountains carved by slow, steady erosion over eons. Because the planet likely experiences tidal locking, one side may face the star in eternal daylight, while the other remains shrouded in darkness. Between these hemispheres, a twilight zone could stretch around the planet, a ring where temperatures balance between hot and cold, and where life might flourish. Winds would circulate constantly, transferring heat and moisture from the bright side to the dark, creating massive storm systems that could last for years. If the planet has a thick atmosphere rich in carbon dioxide or nitrogen, it could spread warmth evenly, transforming the entire world into a stable, temperate environment. The question that burns brightest in every scientist's mind is simple. Could this world harbour life? If Kepler 1649c possesses liquid water, an atmosphere, and a stable climate, then the conditions for biology might be present. The key lies in whether the planet's star has spared it from destructive radiation. Red dwarfs are often volatile in their youth, sending flares that can erode atmospheres. But the host star of Kepler 1649c appears relatively quiet, increasing the likelihood that the planet has retained its protective gases. If so, it could be one of the most promising candidates for habitability we've ever found. The surface gravity, slightly stronger than Earth's, might make the air denser, enhancing its ability to trap heat and maintain stability. In that heavy air, clouds could drift slowly across a dim orange sky, and rain might fall as a soft, constant drizzle. Life, if it exists, would have evolved under perpetual red light. Photosynthetic organisms might use pigments, different from chlorophyll, perhaps black or deep violet, to capture the longer wavelengths of the faint star. Forests of dark, reflective leaves could stretch across the day side, while the night side might host frozen plains under a canopy of stars brighter than any seen from Earth. The Terminator Zone, with its endless dusk, could be the cradle of life, a place of balance and eternal calm. For astronomers, Kepler 1649c represents more than just another data point. It's a symbol of how close we are to finding another Earth. Its discovery reignited the excitement of the scientific community, proving that even among the faintest signals, entire worlds can hide, waiting for patient eyes to find them. It also reminded us that our galaxy may be filled with such planets, small, rocky, temperate, and abundant. The Milky Way might not be a cold expanse of empty stars, but a garden of potential worlds, each with its own version of life. Kepler 1649c in many ways is a message from the cosmos. It tells us that the conditions we cherish on Earth are not unique, that the balance between warmth and light, air and water may repeat itself countless times across the galaxy. Perhaps somewhere beneath that red sky, life is already stirring, sensing the faint pulse of its star, evolving in a rhythm that mirrors our own. And though we may never set foot there, the knowledge that such a world exists reminds us of our connection to the greater universe. We are not separate from it, we are a part of it, reflections of a pattern written across the stars. Among the endless variety of planets scattered through the galaxy, there exists one so bizarre that it seems to defy the very rules of planetary formation. Its name is TOI 849b, and it represents a cosmic mystery, a world that should not exist yet does. Orbiting its star at blistering speed, this planet is thought to be the exposed core of a gas giant that once resembled Jupiter or Saturn. Now, all that remains is its dense metallic heart, stripped bare by the relentless power of its sun. In the great story of the universe, TOI 849b stands as both a survivor and a ruin, a monument to the violence and unpredictability of planetary evolution. The planet orbits a sun-like star about 730 light-years from Earth, completing a full revolution in less than 19 hours. That proximity subjects it to extreme temperatures, over 1500 degrees Celsius hot, enough to melt rock and metal alike. At that distance it lies so close to its star that gravity stretches and squeezes it constantly, generating immense tidal forces that further heat its interior. From space, TOI 849b would glow faintly red, like an ember, its surface simmering under the fierce radiation of its parent sun. The planet's density is astonishing. It's about 3.5 times the size of Earth, but weighs nearly 40 times as much, giving it an iron-rich interior and crushing gravity. For years, astronomers struggled to explain such an anomaly. A planet that massive should have captured thick layers of hydrogen and helium during its formation, becoming a gas giant. But this one didn't, or rather it did and then lost them. The most likely explanation is that TOI 849b was once a giant world whose gaseous envelope was torn away, leaving behind only its solid core. That makes it the first of its kind ever found, a naked planetary heart, the core of a world that lost everything except its foundation. How such a transformation occurred is still debated. Some scientists believe that the planet formed close to its star, where powerful radiation and stellar winds stripped its gases early in its history. Others think it may have formed farther away, like Jupiter, and later migrated inward due to gravitational interactions with other planets. As it spiraled closer, its outer layers may have boiled away, leaving behind a dense relic orbiting precariously close to destruction. Whatever its origin, TOI 849b reveals a hidden chapter in the life cycle of planets, a glimpse at what lies beneath the swirling clouds of the giants we know. If we could peer at Jupiter and peel away its atmosphere, what we might find beneath would likely resemble this strange glowing world. The surface of TOI 849b would be unlike anything we can imagine. The temperatures are so extreme that rock may exist in a molten state, creating oceans of liquid magma stretching across the globe. Metals such as iron and nickel might evaporate into the atmosphere, forming shimmering metallic clouds that condense into rain made of molten droplets. Winds could howl at thousands of kilometers per hour, carrying vaporized minerals across a sky that burns with orange and red hues. There would be no water, no air as we know it, only an inferno sculpted by gravity and fire. For scientists, TOI 849b is a treasure trove of information about how planets live and die. It offers a rare opportunity to study the solid core that gas giants normally hide beneath hundreds of kilometers of dense atmosphere. By observing how the planet reflects and absorbs starlight, astronomers can infer its composition, whether it's made of silicates, metals, or exotic compounds forged under immense pressure. These findings help refine models of how planets like Jupiter and Saturn form, and what might happen to them when their stars eventually expand and consume them. TOI 849b is a reminder that the universe is not static. It is constantly sculpting and reshaping its creations. Worlds are born, evolve, and sometimes are destroyed, leaving behind strange remnants that tell their stories through gravity and light. In a sense, this planet is a survivor of cosmic catastrophe, continuing to orbit its star long after losing everything that once made it majestic. It's both tragic and awe-inspiring, a reminder of the raw power of the forces that shape the cosmos. Though uninhabitable by any measure, TOI 849b teaches us about the fragility of worlds and the resilience of matter itself. It shows us that even destruction can reveal beauty and truth. To stand above such a planet, if it were possible, would be to witness the beating heart of creation laid bare, a glowing sphere of metal and stone, still radiating the memory of the world it once was. Its surface might ripple with molten waves, its horizon shimmering with heat so intense that even shadows would seem to burn. The sky would be dominated by its enormous star, filling half the heavens with blinding light. Every moment would be a confrontation between endurance and annihilation, And yet, in that infernal setting, the planet persists, orbiting faithfully through the ages, a silent witness to the forces that destroy and create in equal measure. TRY 849b is not a world where life could exist, but it is a world that reveals how life itself becomes possible. For every barren core like this, there are countless others that kept their atmospheres, their oceans, their delicate balance. Studying this burned and broken relic helps us understand the survivors, the worlds like ours that managed to hold on. In its molten silence, TOI 849b speaks of the resilience at the heart of the universe, where even ruin has purpose, and even destruction tells a story worth hearing. Just 31 light-years away, in the faint constellation Hydra, orbits a planet that has captured the imagination of scientists and dreamers alike. Its name is GJ 347, and it occupies one of the most delicate positions a world can hold, the outer edge of the habitable zone around its red dwarf star. It is a planet balanced between warmth and cold, light and shadow, survival and sterility. One small shift in its atmosphere could mean the difference between oceans and deserts, between life and lifelessness. Yet in that narrow balance lies the profound beauty of possibility. GJ 357d is a super-Earth, roughly twice the size of our planet and about 6 times as massive. It orbits its star every 55 days, close enough to receive just a third of the sunlight Earth enjoys. That may not sound like much, but with the right atmosphere, one thick enough to trap heat, the planet could maintain temperate conditions where liquid water might flow. If the air is too thin, however, the world would become an icy desert locked in perpetual frost. In many ways, GJ 357d represents the fine line that defines habitability across the cosmos. It reminds us that life does not simply depend on being within a star's habitable zone. It depends on a fragile balance of chemistry, pressure, and time. Its parent star, GJ 357, is a cool red dwarf about 1/3 the mass of our Sun. Though dim, it burns steadily, providing a gentle warmth that could sustain a world for billions of years. The light it emits is red-orange, soft and subdued, bathing the planet's surface in a perpetual sunset glow. From orbit, GJ 357d might appear as a dark teal or deep green sphere, its continents glinting through thick layers of atmosphere. If clouds drift across its sky, they would glow amber under the dim sun, their shadows stretching endlessly over the landscape. The planet's rotation remains uncertain. It might be tidally locked like many worlds around red dwarfs, with one face always staring at its star while the other remains frozen in eternal night. If so, then the habitable region would likely lie along the terminator, the thin boundary where day meets night, where the eternal dawn lingers forever on the horizon. There the temperature could remain mild, the winds constant, and the possibility for life highest. In that narrow band of twilight, the sky would be a canvas of muted red and gold. The dim star would hover low and unmoving, painting the clouds in crimson light. If there are oceans, they might stretch like ribbons along the equatorial zone, shimmering under the star's steady gaze. Ice would dominate the night side, forming towering glaciers that creep slowly toward the light, while the day side might shimmer with vast deserts scorched by the unending sun. Between them, rivers could flow eternally, carrying meltwater from the frozen lands into the illuminated seas. It is in this region that life, if it exists, would find its home. For scientists, GJ 357d has become a kind of testing ground for the boundaries of habitability. If we can determine what kind of atmosphere it possesses, we can learn how fragile or resilient such worlds truly are. Models suggest that if the planet's air is thick with carbon dioxide, perhaps 10 times denser than Earth's, it could trap enough heat to keep the surface warm and stable. Under such conditions, temperatures might hover around the point where water can remain liquid, creating an environment similar to early Mars or even pre-industrial Earth. But if that blanket of gas is thinner, the world would freeze solid. The challenge lies in detecting that atmosphere across the vast gulf of space. Astronomers are now using telescopes like Hubble and the James Webb to analyze the faint starlight that filters through as the planet passes in front of its sun. Each element in the atmosphere leaves a unique fingerprint in that light, revealing whether there are gases like carbon dioxide, methane, or water vapor. The discovery of any of these would be a milestone, a sign that this world sits not on the side of desolation, but on the side of life. Yet GJ 357d is more than just a data point. It's a symbol of cosmic balance. It stands as a reminder that the conditions for life are not binary. They are a spectrum defined by constant change. A slight volcanic eruption, a fluctuation in atmospheric pressure, or the slow dimming of its star could tip the scales one way or another. And that fragility mirrors our own planet's story. Earth too walks that razor edge. Too much greenhouse gas and we overheat, too little and we freeze. The same forces that shaped GJ 350-70's destiny have sculpted our own. To imagine standing on this world is to picture a horizon where fire and ice meet. The ground beneath might be dark and rich with minerals, the air heavy and tinged with metallic scents. Above, the star would hang low, never setting, bathing everything in deep orange light. This silence would be immense, broken only by the constant sigh of wind moving from day to night and back again. Perhaps life there, if it exists, would reflect that duality. Organisms that can tolerate heat and cold, light and dark, constantly adapting to the subtle shifts of their environment. They might live in the eternal dusk, thriving in the narrow zone where balance still holds. GJ 350, like so many exoplanets before it, teaches us humility. It shows that life depends not on perfection but on persistence, the ability to endure, to adapt, to find equilibrium in chaos. In the soft glow of its red star, this distant planet carries a quiet message for all who look toward the heavens, that every world is a story of balance, and that even in the cold outer edges of space, warmth can still be found. 40 light-years from Earth, in the direction of the constellation Aquarius, a faint red star flickers softly against the darkness. It is small, cool, and ancient, barely the size of Jupiter, yet it holds one of the most extraordinary planetary systems ever discovered. This is TRAPPIST-1, and around it circle 7 rocky planets so closely packed that, from the surface of one, the others would appear as bright glowing disks in the sky. Among them lies TRAPPIST-1e, a world that many scientists believe may be the closest thing to a second Earth we have ever found. TRAPPIST-1e is the 4th planet from its star, orbiting once every 6.5 days. Despite that dizzying speed, the planet sits comfortably within the habitable zone, where temperatures could allow liquid water to exist. Its mass, size, and density are remarkably similar to Earth's, suggesting a rocky composition, and possibly even a global ocean. But what makes it truly extraordinary is the company it keeps, 6 sister planets, each one potentially rocky, each one a piece of an intricate cosmic clockwork that has fascinated astronomers since its discovery. The TRAPPIST-1 system is a marvel of precision. The planets orbit in a perfect resonance chain, their gravitational rhythms lock together like the gears of a watch. Each world tugs gently on the next, keeping the entire system stable over billions of years. From space, it would be a breathtaking sight. 7 worlds lined up so closely that their orbits fit well within the distance between Mercury and the Sun. And among that family of worlds, TRAPPIST-1e shines as the jewel, the one most likely to host oceans, clouds, and perhaps life. If you could stand on its surface, the sky would be unlike anything seen on Earth. The dim red star would appear enormous, 10 times wider than our sun looks from home. Its light would be soft and warm, painting everything in shades of a rust and rose. The nearby planets would hang visibly in the sky, some larger than our moon, others moving across the heavens fast enough that their phases could change within hours. Nights would never be truly dark, illuminated by the faint glow of neighbouring worlds reflecting the light of their shared star. The planet is almost certainly tidally locked, with one hemisphere basking in eternal daylight and the other shrouded in endless night. But simulations suggest that its atmosphere could circulate heat efficiently, preventing either side from becoming too extreme. On the day side, gentle winds might sweep across vast oceans, carrying moisture toward the cooler twilight zone. There, under a sky of perpetual dusk, the temperature could be perfect, neither too hot nor too cold for life to thrive. The air might be dense but breathable, the water calm and rich with minerals. In that eternal sunset, strange ecosystems could emerge, adapted to the constant glow of a red sun that never rises or sets. The star TRAPPIST-1 is small and old, but it burns with remarkable stability. Unlike many red dwarfs, which often erupt in violent flares, TRAPPIST-1 seems comparatively quiet. That calmness could have allowed its planets to preserve their atmospheres over billions of years, offering them time to develop complex chemistry. Observations by the Hubble and James Webb telescopes have already begun probing the atmospheres of these worlds. Early results show no thick hydrogen envelopes, meaning these planets are not mini-Neptunes, but true rocky bodies. For TRAPPIST-1e, that's promising news. A thin, stable atmosphere of nitrogen and carbon dioxide could trap just enough warmth to keep oceans liquid while shielding the surface from radiation. If life has emerged there, it may resemble early Earth microbial, resilient, and ancient. TRAPPIST-1e also offers humanity a mirror for reflection. Its environment could show what our own world once was billions of years ago, or what it might become billions of years from now. The planet's age, possibly 8 billion years, means it has had twice as much time as Earth for life to evolve. If evolution took a similar path, the creatures there could be far older and more adapted than anything on our world. But if the planet ever lost its water or suffered atmospheric collapse, it might also be a silent relic, its surface etched with the fossils of what once was. Either way, it represents a profound truth, that even around the smallest stars life's potential endures. The TRAPPIST-1 system has become a symbol of hope for astronomers and explorers alike. It reminds us that the universe doesn't create one-of-a-kind miracles. It repeats them, refining the same patterns again and again. Planets like TRAPPIST-1e are not rare accidents, but natural outcomes of cosmic evolution. Each discovery of such a world brings us closer to answering the oldest question humanity has ever asked. Are we alone? Imagine, for a moment, the first human ship arriving there centuries from now. The crew steps out under the dim red sky, feeling the gravity almost identical to Earth's beneath their feet. They gaze upward and see 6 other planets shining above them, each one a potential world to explore. The silence is vast, but it isn't empty. It hums with potential, as if the universe itself is holding its breath. TRAPPIST-1e may or may not host life, but it has already given something invaluable to ours: perspective. It reminds us that the cosmos is filled not only with cold distances, but with kinship with worlds that echo our own, orbiting faint suns far from home. And in that reflection, we find both humility and hope. About 124 light-years from Earth, in the constellation Leo, orbits a world that has forced astronomers to rethink what it means for a planet to be habitable. This is K2-18b, a super-Earth nearly 9 times the mass of our planet, wrapped in a thick atmosphere and floating in the gentle glow of a red dwarf star. On paper, it sits squarely in its star's habitable zone, close enough for liquid water to exist, but not so close that it's destroyed by heat. Yet the truth of K2-18b is stranger and more complex than that. It is not a simple twin of Earth, nor a gas giant like Neptune, but something in between, a world that blurs the boundaries between the familiar and the alien. The planet was first discovered in 2015 by NASA's K2 mission, a continuation of the legendary Kepler telescope. At first, it appeared to be just another super-Earth orbiting a small star. But when astronomers pointed the Hubble Space Telescope at it a few years later, they detected something extraordinary: traces of water vapor in its atmosphere. It was the first time water had ever been found on a planet within the habitable zone of its star. The discovery electrified the scientific community. Suddenly, K2-18b wasn't just another distant world, it was a potential cradle for life. Later observations by the James Webb Space Telescope deepened the mystery. Spectral analysis revealed hints of methane and carbon dioxide, gases often linked to biological processes. Though the evidence is not yet conclusive, it raised a thrilling possibility that K2-18b might harbour conditions suitable for living organisms, perhaps even simple microbial life, floating within its vast hydrogen-rich skies. To imagine what this planet is like is to step into a realm both beautiful and surreal. K2-18b is roughly 2.5 times the size of Earth, meaning its gravity would be far stronger, enough to hold on to a thick atmosphere that blurs the line between sky and space. The light from its red dwarf sun would bathe the planet in deep orange tones, casting a soft, perpetual twilight across the upper atmosphere. Below, instead of a rocky surface like Earth's, there might be a global ocean stretching thousands of kilometers deep, its surface shrouded in clouds of vapor. The pressure near the lower layers would be immense, perhaps too great for humans or even Earth-like life to endure, but somewhere higher up, in a temperate band of atmosphere, temperatures and pressures could be just right. There, in that golden layer of clouds, could exist an ecosystem unlike any other, one that floats rather than crawls or swims. On Earth, certain bacteria and spores can survive high in the atmosphere, feeding on trace gases and moisture. On K2-18b, similar organisms could drift in the upper air, suspended in droplets, living off sunlight and chemical reactions. They would never touch solid ground, because perhaps, on this world, there is no solid ground to touch. In many ways, K2-18b represents a new kind of habitability, not confined to rocky surfaces or shallow seas, but expanded to include the atmospheres of giant planets. If life exists there, it would challenge our assumptions about where biology can arise. It would mean that the universe is teeming with possibilities, that even worlds we once thought too large or too exotic could host life of their own. Yet the planet also faces challenges. Its host star, K2-18, though relatively calm for a red dwarf, still emits bursts of radiation that could threaten fragile molecules in the upper atmosphere. To survive, life there would need to adapt, perhaps by hiding within dense cloud layers or by repairing itself faster than the radiation can destroy it. Alternatively, magnetic fields generated by the planet's interior might offer protection, shielding its skies from the worst of the solar wind. Scientists are now watching K2-18b closely, measuring every flicker of starlight as the planet transits in front of its sun. Each observation refines our understanding of its air, its chemistry, and its potential for life. The data suggest a dynamic atmosphere, one that might contain hydrogen, helium, methane, and even traces of organic molecules. Some researchers believe it could be an example of a Hessian world, a new class of exoplanet defined by hydrogen-rich atmospheres and global oceans. The term itself blends hydrogen and ocean, describing planets that may be far more common than Earth-like worlds. If that's true, then K2-18b may not be an outlier, but a prototype, the first of many such places where life might thrive in forms completely unlike our own. To stand above this planet, if one could, would be to see infinity painted in orange and gold. The red dwarf would hang large in the sky, its dim light diffused through layers of vapour. Below, the horizon would fade into clouds that stretch endlessly, hiding the deep abyss of the ocean beneath. The air would shimmer with heat and chemistry, and somewhere within that haze, invisible to the eye, might drift the seeds of life. Tiny, resilient, ancient beyond comprehension. K2-18b reminds us that life may not cling only to the solid and the stable. It may float, adapt, and evolve wherever it finds energy and complexity. This strange, glowing world shows that habitability is not a narrow condition but a spectrum, and that the universe's creativity far surpasses our imagination. Perhaps someday, when we look deep into its atmosphere with more powerful instruments, we'll see the faint chemical fingerprints of life, not the life we know, but the life the universe knows how to make. 20 light-years away, in the quiet constellation Libra, lies one of the most controversial discoveries in the history of exoplanet research. Its name is Gliese 590G, though for some scientists that name carries both hope and skepticism in equal measure. When it was first announced in 2010, headlines around the world proclaimed it the most Earth-like planet ever found, the first true Goldilocks world, not too hot, not too cold, but just right for life. For a moment, humanity seemed to be staring directly at its potential twin in the cosmos. Yet almost as soon as it was discovered, the debates began. Was it real? Was it a genuine planet? Or merely a trick of the data? A phantom created by the noise of its star? Over a decade later, the mystery of Gliese 591G still endures, a ghostly reminder of both the excitement and the uncertainty that define our search for other worlds. The planet, if it exists, orbits a red dwarf star named Gliese 581, a small, cool and long-lived star about 1/3 the mass of the Sun. This system had already fascinated astronomers for years, hosting several confirmed planets ranging from hot super-Earths to cold, distant ones. But Gliese 581G stood out because it appeared to sit right in the middle, in the star's habitable zone where liquid water could exist. Early calculations suggested that it was about 3 times the mass of Earth, with gravity strong enough to hold an atmosphere, and that it received just the right amount of light for comfortable surface temperatures. To the world's media, it was immediately dubbed Earth 2.0. Yet as data from other observatories poured in, the picture grew murkier. Some teams reanalyzed the same measurements and could not find the planet at all. Others claimed that what seemed like a planetary signal was instead the star's own natural wobble, magnetic cycles masquerading as orbital motion. For every paper confirming its existence, another would refute it. The result was a scientific tug-of-war that continues to this day. Still, the idea of Gliese 581g refuses to die, and for good reason. Even if it turns out not to exist, it has reshaped how we search for habitable worlds. It reminded us that the line between discovery and illusion is razor thin, and that true science advances not through certainty but through careful doubt. But let us for a moment imagine that Gliese 581g is real, that it truly orbits its quiet red sun 20 light-years away. What would it be like to stand on its surface? The star above would glow dimly, bathing the landscape in a soft reddish light, never bright enough to cast sharp shadows. The sky might shimmer in dusky tones of crimson and violet, with clouds of water vapour reflecting the faint warmth of the star. Because the planet likely rotates slowly, or is tidally locked, one hemisphere would face perpetual day, while the other would remain in eternal night. Between them would lie a twilight belt, the Goldilocks strip, where the climate could be mild, where the temperature might allow rivers to flow and oceans to glisten beneath the dim red sun. In that band of eternal sunset, life could flourish. Plants might evolve to absorb the faint red wavelengths of light, turning their leaves black or deep purple to capture every photon. Simple organisms could thrive in shallow seas, feeding on minerals and organic compounds. Over millions of years, ecosystems might form that are perfectly adapted to the steady, unchanging glow of their sun, life built for constancy rather than change. For humanity, Gliese 581 represented something more than just a potential world. It was a symbol of possibility. When it was announced, it reignited the collective imagination of a generation. For the first time, people could point to a real location in the sky and say, that could be another Earth. Artists painted its landscapes, filmmakers wove it into stories, writers dreamed of civilizations living under its red skies. The planet became a mirror reflecting our longing for connection, proof that we are not confined to one fragile world, but part of a universe brimming with potential homes. Even if it turns out to be an illusion, Gliese 581g changed the way we look at the stars. It showed us how close we are to finding planets like our own, how technology and perseverance are bringing us to the edge of discovery. The controversy surrounding it taught scientists humility and caution, but also courage. The courage to look again, to question, to refine, to never stop searching. Because of that, Gliese 581 has earned a special place in the story of exploration. It symbolizes not just the worlds we find, but the ones we imagine. And imagination, after all, is the first step toward discovery. Perhaps in the years to come, with better telescopes and more precise data, we will know the truth. Maybe the signal will reappear, strong and undeniable, confirming that the planet truly exists. Or perhaps it will vanish forever, leaving behind only its legacy, the dream of another Earth orbiting a faint red star 20 light-years away. But even if Gliese 581g never turns out to be real, what it represents absolutely is humanity's relentless curiosity, our refusal to accept isolation, and our belief that the universe must hold other places where life, in all its infinite forms, might have found a way to begin. Far beyond our solar system, about 1,200 light-years away in the constellation Lyra, orbits a serene and ancient star known as Kepler 62. Around it spins a family of 5 planets, each tracing its delicate path through the cold black of space. Among them, one stands out as a particularly promising candidate for life, Kepler 62f. It is a planet that seems to belong to both the past and the future, a vision of what Earth might have been billions of years ago, or what other Earths might become long after ours has faded. Discovered in 2013 by NASA's Kepler Space Telescope, Kepler 62f captured immediate attention because of its position, right at the outer edge of its star's habitable zone. It receives only about 41% of the sunlight Earth does, Yet with the right kind of atmosphere, it could sustain liquid water across much of its surface. It is a little larger than Earth, about 1.5 times its diameter, suggesting a stronger pull of gravity and perhaps a denser atmosphere. This combination could make it an ocean world, a planet covered in deep, endless seas that conceal unknown mysteries below their dark surfaces. Imagine standing above that world, hovering above its blue expanse. You would see a globe dominated by water, no vast continents, perhaps only scattered archipelagos and small islands rising like jewels from the waves. The light from its orange star would be soft and warm, casting the oceans in shades of copper and indigo. The sky might be hazy and dense, filled with thick clouds that move slowly across the horizon. Rain would fall often, feeding the great circulations of the planet's climate system. It would be a world in motion, winds carrying moisture from the equator to the poles, powerful currents churning below the waves, and a biosphere that thrives beneath the surface where sunlight fades into twilight. If life exists there, it may have begun in those oceans much as it did on Earth, in the quiet chemical interplay of heat and minerals near volcanic vents. Microbes could inhabit the deep waters, feeding on energy from the planet's core, while more complex organisms could drift through the upper layers, photosynthesizing the weak but steady light from the distant sun. Their pigments might be darker than anything on Earth, evolved to capture every photon of the faint orange glow. Whole ecosystems could rise and fall within the waves, unseen by any eye, their rhythms shaped by tides and storms. Kepler 62f's long orbit takes 267 days, close to what we call a year. Yet its seasons, if they exist, would be gentler, dictated more by atmospheric circulation than by axial tilt. The air might be thick with carbon dioxide, acting as a natural greenhouse to keep the surface warm. If the concentration of these gases is high enough, the temperature could stabilize near the melting point of ice, creating a world perpetually cool but still alive with water and motion. From a scientific standpoint, Kepler 62f is one of the best-known examples of a superhabitable planet, one that might actually be more suited for life than Earth itself. Its slightly larger size means it could retain its atmosphere longer. Its star, cooler and older than the Sun, burns steadily and will live for billions of years to come. Together, these factors create stability, the most precious commodity in the cosmos. A world like this could nurture life slowly and gently, allowing it to evolve over unimaginable spans of time. In such an environment, evolution would not rush. It would meander. Species might persist for eons, adapting not to sudden change but to the subtle flow of tides and currents. If intelligence ever emerged there, it would grow under skies that never threaten extinction, where catastrophe is rare and time feels infinite. The people of such a world, if they exist, might measure their history not in centuries but in ages. For astronomers, Kepler 62f represents a key in the puzzle of habitability. It challenges the assumption that planets must mirror Earth's temperature and orbit to sustain life. Instead, it shows how many paths nature can take to achieve the same end. Its discovery also marked a turning point in how we think about Earth-like worlds. Before Kepler, scientists imagined that habitable planets would be rare gems. But Kepler 62f proved otherwise. It showed that even stars smaller and dimmer than our Sun could host planets of water and air, orbiting at just the right distance. The galaxy, it seemed, might be filled with such worlds, oceans upon oceans, each one a potential cradle for life. To imagine the view from Kepler 62f's surface is to imagine serenity on a planetary scale. The horizon would curve gently under a soft orange sun. The wind would carry the scent of salt and rain, and the sound of waves would echo endlessly across the vast empty seas. There might be no land to divide or conquer, only water connecting everything. If intelligent life ever arose there, its civilizations would be shaped by the ocean. Explorers, navigators, and philosophers gazing upward at their calm ancient star, wondering if anyone else drifts across the cosmic sea. Kepler 62f is a reminder that not all habitable worlds need to resemble our own. Some may be colder, some wetter, some wrapped in endless clouds. Yet each one holds the same fundamental potential, the spark of chemistry that leads to life, the quiet persistence of time, and the promise that we are not alone. When we look toward it, across 1,200 light-years, we are not just searching for another planet. We are glimpsing a reflection of the same miracle that happened here. the miracle of a world awakening to itself. Just 11 light-years away, almost within reach of humanity's imagination, orbits a small, dim red star called Ross 128. It's not bright enough to be seen with the naked eye, but it has quietly become one of the most intriguing destinations in our search for life beyond Earth. Around this unassuming star revolves a planet known as Ross 128b, a world so close, so stable, and so Earth-like that some astronomers have begun to call it our quiet neighbour. While most red dwarf stars are turbulent and violent, blasting their planets with radiation and solar flares, Ross 128 is unusually calm. Its surface barely ripples, its magnetic storms are weak, and its light is steady. That serenity might have given Ross 128b the greatest gift any planet can have. Time. Time for its atmosphere to survive, for oceans to endure, and perhaps even for life to evolve in peace. The planet completes one orbit in just under 10 Earth days, circling its star at a distance 20 times closer than Earth is to the Sun. That may sound perilous, but the star's dimness balances the equation perfectly. Ross 128b receives roughly the same amount of energy from its Sun as Earth does from ours, placing it right in the habitable zone. Its surface temperature could hover around a mild 20 degrees Celsius if it has a stable atmosphere, a climate that sounds almost comfortable by human standards. It is slightly larger and more massive than Earth, likely rocky, with gravity that would feel a little heavier beneath one's feet. If we could stand on its surface, we might see a world bathed in perpetual warm dusk. The red dwarf would dominate the sky, appearing several times larger than our Sun, glowing with a faint pink-orange light. Because Ross 128b likely keeps one face always turned toward its star, that hemisphere would bask in eternal day while the other lies in unending night. Between them, a twilight zone could stretch around the planet, a place of gentle warmth and dim, rosy skies. The air might be thick and calm, coloured with the muted glow of a red sun that never sets. In that twilight ring, clouds could drift lazily above shimmering oceans or broad continents of stone and dust. The light would be strange but beautiful, a soft radiance that never grows brighter or fades away. For life, such constancy could be a blessing. Evolution could proceed without the disruptions of extreme seasons or rapid environmental change. Plants or analogues to them might evolve to absorb red wavelengths efficiently, appearing black or dark grey to human eyes. Their pigments would capture the faint light that filters from the small star, turning it into energy slowly but steadily. Beneath that alien flora, simple organisms could flourish in shallow seas, thriving in the mild and stable climate. The chemistry of such life might not differ much from ours, carbon-based, water-dependent and oxygen-producing, because nature, when given time and stability, tends to find similar solutions. If the atmosphere of Ross 128b contains carbon dioxide, nitrogen and perhaps traces of oxygen, the greenhouse effect could maintain comfortable temperatures across the twilight zone. But if the air is too thin, the night side could freeze solid, forming ice sheets miles thick. The delicate balance between heat retention and radiation loss would define the planet's entire existence. It would be a world of balance, a silent dance between fire and frost, much like the one Earth performs every day. What makes Ross 128b particularly exciting is its proximity. At just 11 light-years away, it is one of the closest potentially habitable planets to our solar system. Future telescopes, both on Earth and in space, will be able to analyze its atmosphere directly, searching for the spectral signatures of life, oxygen, methane, water vapor, or other biosignature gases. If any of these are found, it would be a monumental discovery, the first true evidence of a living world orbiting another star. Scientists already regard Ross 128b as one of the most promising candidates for such detection. Unlike most red dwarfs, its star's calmness means its planets are less likely to have had their atmospheres stripped away. That tranquility makes it a precious anomaly in a galaxy filled with stellar violence. It could mean that, while billions of planets exist, only a few orbit stars gentle enough to nurture life for billions of years, and Ross 128b might be one of them. Imagine the night sky from that world's dark hemisphere. The stars would blaze even more brilliantly than they do from Earth, unblinking and clear through an atmosphere free of pollution. Somewhere out there, a small blue point of light, our Sun, would shine faintly among the constellations, too dim to notice without instruments. And on that pale dot, another intelligent species might be wondering the same thing we are, whether someone else looks back. Ross 128b carries a quiet kind of hope. It doesn't boast extreme features or dramatic phenomena. It doesn't dazzle with storms or mystery. Its beauty lies in its normality, in the possibility that it might simply be another world where nature found its footing, where chemistry became biology, and biology became something more. It stands as a nearby reminder that life doesn't always need spectacular circumstances. Sometimes all it needs is stability, patience, and a little light from a calm sun. In a galaxy full of chaos and fury, Ross 128b whispers of peace. It suggests that somewhere close to home there may be a world that, like ours, breathes quietly under the warmth of a gentle star, waiting for us to listen. Only 4 light-years away, practically next door in cosmic terms, orbits a small, faint red star known as Proxima Centauri, the closest star to our Sun. And around that star moves a world that has become the most compelling target in humanity's long search for life beyond Earth. Its name is Proxima Centauri b, and its proximity transforms it from a distant curiosity into a reachable dream. It is the first exoplanet we can truly imagine visiting within the lifetime of our civilization, a real destination shimmering just beyond the edge of our solar neighbourhood. Discovered in 2016 by the European Southern Observatory, Proxima b quickly captured global attention. It is roughly 1.3 times the mass of Earth, and orbits its tiny star once every 11.2 days. Despite that dizzying speed, it sits within the habitable zone, the narrow region where temperatures could allow liquid water to exist on the surface. Because its parent star is much cooler and dimmer than the Sun, that close orbit doesn't roast the planet. Instead, it bathes it in a soft crimson light, enough to warm but not destroy. The discovery was electrifying not only because of what the planet is, but because of where it is. So close that telescopes of the next generation will be able to study its atmosphere directly. If Proxima b harbours air, oceans, or even the faintest hint of biology, we may soon know. But as with all red dwarf worlds, paradise and peril coexist. Proxima Centauri, though calm by cosmic standards, is prone to violent solar flares that unleash torrents of radiation hundreds of times stronger than anything from our Sun. Such storms could strip away a planet's atmosphere or sterilize its surface. Whether Proxima b has survived that bombardment is one of astronomy's most profound questions. Some models suggest it might have retained a thick blanket of gas, replenished by volcanic activity or shielded by a strong magnetic field. Others argue that it could be a barren rock, its oceans long evaporated into space. Yet even a lifeless Proxima b would remain one of the most important worlds ever found, because it lies so near, because it shows us what's possible. To imagine standing there is to picture an alien twilight that never ends. The planet is almost certainly tidally locked, meaning one hemisphere forever faces its star while the other lies in eternal darkness. On the day side, the red dwarf would loom enormous in the sky, glowing like a deep ember. The air, if it exists, would scatter that light into hues of copper and rose, filling the landscape with an unearthly radiance. The ground might be composed of dark, iron-rich rock glinting faintly under the crimson sun. Winds would sweep constantly from the hot hemisphere to the cold, swirling through the narrow band of dusk that circles the planet, the terminator zone, where temperatures might be mild enough for liquid water. There, in that eternal dusk, oceans or lakes could exist, shimmering like pools of blood-coloured light under the dim star. The night side, meanwhile, would be frozen and still, illuminated only by auroras, vast curtains of red and green light ignited by the planet's magnetic field. If life exists on Proxima b, it would likely cling to that terminator region, where light and shadow meet. Organisms might evolve to absorb red wavelengths efficiently, appearing black or dark purple. Their world would never know sunrise or sunset, only the steady glow of a fixed star and the faint glimmer of the Milky Way overhead. In that perpetual twilight, perhaps something moves. Not a civilization like ours, but something simpler. Microbial mats beneath shallow water, drawing energy from the faint light that seeps through the clouds. Perhaps After billions of years, evolution could shape more complex beings, their senses tuned to the dim glow of their world. And if they looked up at their sky, they would see our sun, a tiny yellow star among thousands, and wonder if someone lives there too. For astronomers, Proxima Centauri b represents both the end of one era and the beginning of another. It is the first truly nearby world that might be habitable, the first target for interstellar exploration. Concepts like Breakthrough Starshot, a fleet of tiny laser-driven spacecraft that could reach Proxima b within a human lifetime, have transformed from fantasy to engineering challenge. In the coming decades, we may send probes there, capturing real images of its surface and atmosphere. The idea that we could one day stand on another world, orbiting a different sun, no longer feels like science fiction. It feels inevitable. But Proxima b is more than a destination. It is a reminder of how connected everything in the universe truly is. The same physical laws that shaped Earth shaped this world. The same chemistry that brought forth life here could be at work there, and the same curiosity that drives us to explore is, perhaps, universal. A spark that might exist wherever consciousness takes root. When we look toward Proxima Centauri in the southern sky, we are looking at the nearest frontier, the threshold between our solar system and the rest of the galaxy. Somewhere in that faint red glow, a planet orbits quietly, holding its secrets. It could be a barren wasteland, scorched and frozen by radiation, or it could be something far greater. A living world, breathing under a dim crimson sun, waiting for the day when the first human eyes see its horizon. Whatever the truth may be, Proxima Centauri b stands as a symbol of what lies ahead. It reminds us that the universe is not empty. It is full of destinations, each carrying the potential for discovery, each whispering the same message, that we are part of something vast, beautiful and unfinished. And somewhere, just 4 light-years away, that message glows softly in the red light of our closest neighbour.